I'm joined with my co-host, Sean, who will be doing all of the presentation for us. Let's get rolling. A quick note of housekeeping, if you have any questions, please type them in that chat box. If you use a question mark, it will pop into our QA mode and we'll be able to address those later. So with that out of the way, Sean, please feel free to introduce yourself and let's get rolling.
Sure. So let me just share this. Jim, you can see that, right? I hope. So we're going to talk about agentic methods today. If you haven't heard about agentic methods, that's okay. They have gone under many different names, but that term really does serve, I believe, to differentiate them from the other ways that companies are trying to engage their users. A lot of what we're going to talk about today is things that we have developed by creating an agentic AI for AMP. I'm the chief data scientist for AMP. I designed most of that system. I've tried to keep this webinar at kind of a mid-level. I didn't want it to just be a skimming overview of the topic, but I also didn't want to dive too much into the weeds. So I will get into some technical topics, but I'm going to try to keep them accessible. As we go through, if you have any questions, just type them in the chat with a question mark. That will flag it to Jim as a question, and we will bring those up. We'll probably hold most questions to the end, unless you have a question where like I'm not making sense or something. Then yes, please tell me. I will stop and I will clarify. But otherwise, we'll try to hold most questions to the end. I've just found that presenting this topic multiple times now, I find that often the most common questions actually get answered in other parts of the presentation. So, and I will try to hold quite a bit of time at the end for us to be able to do some Q&A. So, given that, let's get started. So, people talk a lot about acquiring users and retaining users. And that's a kind of antiquated way of thinking about the problem. You don't acquire or retain users anymore. There was a time when that was more true, but it's not true anymore. Now you acquire and retain attention. Just because a user is technically in your system, and just because technically you're able to communicate with them over certain channels, does not mean that they are getting value from your app, doesn't mean that they are providing value to you as a customer. Really, what everyone is working for now is finding ways to continuously earn each user's attention over and over and over again. You can see how this is played out in the history of software designed for user engagement. If you go back several years to the kind of early CRM platforms, it was all about just getting users' contact information in one place. Like you know who everyone is, basically a Rolodex, with a little bit of marketing automation added on. Because the main thing was just, we need to know who all these people are and how do we contact them. But over time, it became apparent that that was not enough. You needed ways of being able to target your users more efficiently and appropriately. And that gave rise to customer data platforms where you unified all of your data, you focused on audience building, things like that. And even more recently, that has more evolved from a platform more to full customer data infrastructure, where people realized that you needed, there's so many innovations in machine learning. You needed to leverage that. You needed to orchestrate journeys, because it's not just one touch point that you give to a customer and suddenly they're going to activate. And so it's become a lot more involved. But the trend in all of that history has been a focus on providing data to human operators. You have people on your team, and you're trying to get all of that data in one place so they can pick it up and use it. And that is exactly the failure of customer data infrastructure up to this point. That we've been making more and more data available to the human operators, but we haven't done anything to get better operators. And that is the innovation of agentic customer data infrastructure. There are companies that have already been building this in-house for years. And what characterizes them is they are often the market leaders. I'm not just talking about the Amazons of the world. I'm talking about the Spotifys, the Netflixes. I would be surprised if they call these things agentic methods in their system. They call it lots of different things. The nomenclature hasn't really solidified yet. But what ties all of those different market leaders together is they have created systems and then given agency to the systems themselves to proactively make decisions. That is a difficult thing for enterprises to do, to give up some of the agency of their human operators and give that to essentially a computer. But that has what has allowed them to pull ahead of their competitors. So if we look at how an enterprise normally manages their customer data infrastructure, what you have on one side is all of your data, and it's lots of different silos, and yes, you need to bring that all together. And on the other hand, you have a whole bunch of surfaces. These are places you can put information in front of a customer. This could be traditional marketing channels, things like email, push notifications, SMS, but also in your app itself. On your website, there is content there that gets presented to the user, and there is no technical reason why that content needs to be the same for every user. You can push different content, and for instance, people who use recommender systems, that is what you're doing. You're pushing different content. So the traditional way of mapping all of this data to all of those surfaces is to funnel it through some kind of data science or analytics capability. You'll usually have some kind of a data hub where you decide what data to put into the hub, you transform it in various ways, you stage it, you make it all available for your teams to then go and pick it up in the form of maybe direct queries or dashboards or reports. And then they're supposed to take that information and look at it, understand it, digest it, and then act on it. So for example, you might take your most recent visits from your website and your app to find out how long it's been since you saw a user. And then you might look at your point of sale system and create some kind of measure of lifetime value. You put both those things together and you end up with what we could call a high value active user segment. Once you have that segment, then the humans on your team can look at that and say, okay, well, how does that segment perform? Who's in it? How many people are in it? And they can take it and act on it. They can go put that into any standard automation system and say, under these conditions, I want you to send this message to these users. The problem with that is it's full of bottlenecks. It's not just a single bottleneck. There are engineering bottlenecks in getting the information in. There's analytics bottlenecks in standing up and even deciding what analytics you need. There's operations and CRM and product bottlenecks in getting people to actually use that information well and in a timely manner. The whole system grinds to a halt, not because you didn't get the right data, but because you had to rely on people at crucial moments, and it was too much information for those people to handle. This is what companies that, with good intentions, try to stand up a one-stop shop for their data end up facing, is that they end up having to increase their headcount over and over and over again because they get all of their data and realize it's still not enough to make good decisions. And in fact, realize that they're not even leveraging all of that data. There is no data science team big enough to actually create individual analyses for each individual user in your app. And even if there was, there is no CRM team big enough to be able to act on each individual pattern. It just doesn't happen. But that is exactly what you can do if you give agency to a synthetic agent. If you've used something like ChatGPT, you have used an agent. GPT inputs and outputs language within constraints. So if you tell it that you want something in English, it will give you something in English. If you want it in German, it gives it in German. If you want it in Python, then it will give you the code. But it's taking initial instructions about what you want or don't want, and then it's being creative within those constraints. Now, The agents we created for AMP input and output behavior. They take all of the information from your app and your website, your event stream, any event that you've instrumented, no matter how many. Ingest user attributes, even ingest things like your content management system. If you have inventory, a catalog, things like that, it can ingest that. And it can take that information and then decide what information to push to which users and in what situations. It takes initial instructions from human operators of what is a good or bad behavior, what kinds of things should it be paying attention to, what constitutes a good outcome, things like that. But in the end, the agent is given a lot of freedom to be able to be creative, to try different things, to see what works, and to double down on what works. In order to do that, we need a way of giving what is essentially a computer program, a way of mimicking certain core human capabilities. You've seen this with GPT in that it mimics human language. Language isn't so much of an issue for our agents because the content is populated, so we can make sure things are on brand and things like that. But there's still the decisions of which content do you pick, who do you send it to, what time do you send it, stuff like that. In order to do that, agents need to have a capability of forming value judgments. They need to be able to engage in teamwork to share information. They need to be able to plan ahead, to think about the second order consequences, things like that. And they also have to have some sort of a memory, some way of retaining lessons learned. So let's dive briefly into each of those and look at how we allow a computer to do those things that normally a human would do. So agents have to mimic value judgments. We do this through what is called a surrogate model. So if you are, say, an e-commerce system, what you ultimately care about is purchases. If you're a streaming system, you care about views, listens. These are conversion events. So if you just take a standard machine learning approach and say, well, I want to maximize conversions, and you just feed the conversions, that's a limited amount of information for the system to work on. And it doesn't give the system the ability to know whether you are headed in the right direction. A lot of times a single touch point, in fact, most times a single touch point is not enough to get a user to convert. You have to be able to approach them again and again, which means you need to be able to do what humans do all the time, make a judgment about, did that move them closer to where I want them to be, or did that move them further away? So a surrogate model takes that conversion event, that main thing you care about, and it models proxies among all of your other events. What you're seeing here is different proxy scores, different surrogates, for the top 20 and the bottom 20 events from one of our customers. That looks at, basically the more blue a square is, the more that's moving someone towards a conversion event. The more red a square is, the more it's moving someone away from a conversion event. And we try that out in several different settings. For instance, for new users, for users who've been on the app for a week, a month, more than a month, things like that. What this allows the agent to do is to try things and then pick up on even small signals. So even if a user does something very minute, that's very distant from a conversion event, the agent is still able to make a value judgment about whether or not that was a good thing or a bad thing and then react appropriately. Agents also have to be able to engage in teamwork. Each user in your app, each individual user gets assigned their own agent. So think of this as a segmentation where each segment is one person. That agent then tries out different things. But sometimes what the agent's trying out doesn't work. Now, we could just tell them to keep trying more and more stuff, but that would be a really inefficient way of going about the problem. So instead, what we do is we create embeddings of behavior. This is where we take all of the event stream data and we organize it into a map. What you can see here is Humans usually have a hard time dealing with anything more than 3 dimensions. So I've reduced it to 3 dimensions here. But each of those colors you see on there is actually another dimension, a different gradation. You can actually have as many dimensions as you want. And what this allows the agent to do is to quickly find the agents of other users who are most similar to the user it's trying to satisfy. So if it's trying things with a user and it can't find any good solution, it then looks around, finds a bunch of users who are similar, and talks to their agents and says, have any of you had success? And then some of them say, yes, we've had success doing this, this, and this. It can then take those lessons back to its user and try those, so it can learn much more efficiently and really much more quickly get to a good solution. They also have to be able to plan. So when you look at sending a message, for example, if you look at a typical A/B testing situation, you have message A, you have message B, you try them out, message A performs better. What do you do then? You can't send message A again. You already sent it. That would be a bad user experience. People notice that kind of thing. You need to be able to send a different message that has similar qualities to the message that succeeded. To do that, we generate a knowledge graph of our content. So as you create all of your different ways of pushing information to users, each of these gray dots you see in this graph is an individual sendable message. Each of the colored hubs you see in this graph are different value propositions, different offering categories, and different kinds of call to action. So the agent is able to try different messages, and then when it finds something that works, it can then go to the nearest hubs and make decisions about what the next content to send should be. If something doesn't work, it can actually decide to find the nearest hub and then find content that's distant from that hub to try something totally new. It can also do that even if it's working in order to try to cross-sell. So it can look at, well, you've had success with selling shoes, maybe I should try shirts now. All of this is possible because we create these knowledge graphs that connect all of this content together into a landscape that the agents can then traverse. It's worthwhile talking a little bit about this because this is actually the core of what differentiates an agentic system from a non-agentic system. And it's what you can see in a lot of companies that are having success in this area. For example, New York Times had a really good piece, it was probably a couple months ago now, about Netflix and their tagging. Netflix curates over 3,000 tags. They actually have a full-time team that just focuses on deciding the tags and deciding where to apply them. And it uses this to make decisions automatically about what to recommend to people. So if you look at a simpler way of recommending content, you could say, well, Netflix is in the business of showing films, so how about we look at common actors? People who like one actor might like another movie that they're in. But if you did that and say someone watched Breaking Bad, you'd say, okay, Bryan Cranston's in Breaking Bad. What else on Netflix right now is Bryan Cranston? And you'd go to Kung Fu Panda 3, which arguably is not a great match. However, if you look at one of the tags for Breaking Bad, it's dark. And if you look at another film that has that same tag, you get to John Wick, which is arguably a much better match. It's much more in line with the starting point. This is what systems that are given agency do. Instead of trying to segment the user base so a human can then try to figure out what's going on, you segment your content, you tag it, and then allow the agents to go through and navigate that and try different things. You can see a similar thing with Spotify. They have over 6,000 genres. There are not over 6,000 genres. Like, no one really knows what things like electro house, Indonesian pop are. But those tags are used to show fine gradations in the huge amount of content that Spotify offers. And that allows them to then find relationships between tags, to be able to track how each one is doing, to be able to recommend new tags that are similar, things like that. This is what an agentic system does. This is also what we allow people to do in AmpSys, and this is a screenshot of part of our UI, where you create a message like you would normally, but then what you would not do in a normal system, you actually highlight sentences, and then you can create alternate versions of that sentence that speak to different product categories, different value propositions, things like that. And as you create those different alternates that can then be mixed and matched, you tag them with categories that are relevant to your business. That gives agents the ability to know your strategic priorities. They use those tags as a proxy for your business priorities and navigate them and find out which tags each user responds to well. They do this by committing to memory a weight for each tag. If you send out a message to a user about shoes that are high quality, and a user responds well to that, they go look at the product, maybe they buy, things like that, then the agent will have a concept, a tag of shoes, and it will take whatever weight it has and it will increase that weight. And it'll have a concept, a tag of quality, and whatever weight it has for that, it will increase that weight. The more people don't respond, the more it decreases that weight. So by trying lots of different things, agents can very quickly become quite opinionated about what a user likes and doesn't like, and those scores can become directly accessible. So this is just a few users from one of our customers, and it's just the tags they have for their value propositions. You can see one user cares very much about convenience, not so much about the other things. One user cares kind of equally about assortment and value, but not so much the other stuff. Another one, assortment and bestsellers. Every user can have their completely unique profile because of the way an agentic system works, trying lots of different things and then distilling that information into weights. Once you have these weights, it opens up tons of possibilities to communicate with users and engage with users, to capture their attention in ways that you didn't have before. For example, just having weights attached to value propositions allows you to take the exact same item in your inventory, say it's a toaster, and you can present it in entirely different ways. You can change the hook, the title that you're presenting it on in your app. You can change the description. You can change anything you want. You can change the message. It allows you to take the same content and make it an entirely different experience for each user. Now, that's just what dealing with content. You can actually tag things that are not content. You can tag times of day and days of week. You can tag frequencies, which allows you to then vary the way you communicate with users. For example, this is a user from one of our customers in the US. The gray hills that you see are periods of more or less activity on the app. And the dots you see along the bottom, the blue dots, those are messages that the system sent. And the red dots along the top are funnel activity, with the darkest dot being an actual conversion event. So you can see that this user started on the app, didn't convert, but poked around, and then went away. And we messaged them a couple times, and they didn't do anything. We messaged them again, didn't do anything. And you can see over time, we start to stagger the messages at larger intervals until we say, you know what, they're not responding. We don't want to bug them, because then we just train them to ignore us. So let's pause it for a little bit. And then we try it again, and they respond. In fact, they responded very quickly. So, okay, we're on to something. They then do some more, we respond some more, then we try it again, they respond to that, and eventually they convert. And then we don't want to push a good thing. Eventually they convert more, and then we start responding more frequently to that because they've given us more signal. No human was involved in any of these decisions about when to send or what to send. When it decided to back off, that was the agent automatically deciding to back off. When it decided to speed up or start again, that was the agent deciding to do that. And this allows you to have completely different journeys for every single user. For example, this is another user from the same app. This is a user that I personally this would not fit my preference, but despite all the messages they're receiving, look how much they're converting. This is a good user experience for this user, and it's entirely different from the previous user. And again, no person had to go in and say, this is how you do it. This is when I want you to send. This is what I want you to send in which place. You can also tag more than just time and content. You can actually tag entire systems if you have a data science capability in-house. For example, this is from one of the apps we work with in India. They had 4 different recommender systems for recommending food. Now, if you're in the app, having multiple recommender systems isn't a bad thing because you have landscape. You can put recommendations from one system here, one system here, one system here, one system here, and let's see what the user picks. But if you are proactively reaching out to the user, you can't do that. You have to pick one. And so one of their questions to us when we started working with them was, how do we pick the best recommender to use? With an agentic system, you actually don't have to pick the best recommender. What we did is we tagged different content with to leverage different recommendation systems, and the agents were able to pick which one worked for each user. And what we found was there was a best performing system. 45% of users exclusively preferred system A. But that's still a minority of users. And in fact, 9% of users exclusively preferred the worst performing recommender system. If we had done more of an A/B testing approach and said, oh, well, C performs the worst, just get rid of it, we actually would have been torpedoing the user experience of almost 10% of the customers. So by tagging this information, we allow the agents themselves to go through, find out individual preferences, and push information from your internal systems to your users on a programmatic basis. So that's an overview of how agents work and the ways that agentic learning can be used. Let's talk a little bit about results. What kind of results can you get from using this kind of system? Now, we do have a whole bunch of different case studies that on request, we're happy to share those that show different ways that we have improved experience. But like I said, I wanted to dig a little bit deeper into this. So let me talk about some of the things that we don't talk about as much maybe. We did a randomized control trial with one of our customers. We actually randomly partitioned their user base into 3 groups. One was a group that took a fully agentic approach. The AMP system messaged out users when and how the agents decided. We retained another random subset of their user base to take a static approach, where they kept them in their old system and set up segments and triggers and all the different things that you normally would do in that kind of system, and let that go. And then we took another subset and we actually stopped messaging them entirely, so we could see what would happen to people who simply weren't contacted. What you can see in the first 2 columns here is the visit rate of each of these systems across, I think it's 8 different product categories. So this was an e-commerce system, so there was toys and women's clothing and things like that. So we ran the experiment in 2 phases. Phase 1 just ran regular messages for 8 weeks. Phase 2, for 3 weeks, we actually added in hefty incentives. We're talking like 60 to 70% off deals to see how that influenced. You can see the agentic system got a higher visit rate in most cases, not in all. But if you look at the baseline, this is where we took the control group and we looked at what normal engagement activity looked like, uninfluenced engagement activity, organic, during the times that each of the systems messaged. And you can see that the static system consistently had a much higher baseline. That's because in a static system, you can't decide individually for each user when to message them at different times. A human can't keep up with that kind of workload. So what you do is you say, well, I think that Fridays at 6 o'clock are a good time. We're going to send out a bunch of people messages at Fridays at 6 o'clock. And so what the static system was doing was sending a lot of messages to people who would have gone to the app anyway. And in fact, when you look at the percent improvement over the baseline, that's the last 2 columns of this, this table, you can see a few red areas for the static system. Those are instances where they would have got, based on the control comparison, they would have gotten better engagement if they had done nothing. You can see that the agentic system never fell that low. We were always getting value add because the agents were making decisions about individually, is it worth putting information in front of a user right now in order to activate them? If putting information in front of them is no better than doing nothing, the agent backed off because it doesn't want to bug people. You can't do that kind of minute orchestration with a non-agentic system. Also, agentic systems allow you to find value in niches that normally a human team would not have time to prioritize. This shows results from another customer that was looking at who they messaged, how many users they messaged. So we had equal numbers of contacts assigned to an agentic system and to their static system, but they actually messaged only a small portion of their users that were assigned to them because they didn't have the capacity on their team to create all of these different segments and create differentiated content for all of them. So what they tended to do is what a lot of teams tend to do. They found segments that they thought were high value and they pushed them a lot. And they did get good response from that segment. However, because we were able to assign an individual agent to each individual user, we were able to reach everyone that was reachable. And therefore, we're able to pull out value in places that had fallen through the cracks in the static system. So we were able to find users who really were not high value at all, that were not likely to respond. But because there were so many more of those users, we were able to get a lot more bottom line value from them. If you get like 10% of the engagement rate from a large segment of users, it's still 10% of a much bigger pie. We also can find cost savings with agentic approaches. This is from another one of our customers where they were trying to do last minute deals. This was a engagement platform. So they were trying to, it was similar to kind of Uber, where you have people who are presented with opportunities and they pick up the opportunity or don't. And they were sending these last minute deals through SMS in order to get them right in front of people. But SMS costs a lot more than, say, push notifications does. So they were sending out blasts to everyone in order to try to fill these slots that they were trying to fill. When we switched to an agentic approach, not only did we see a modest lift in conversions, but we actually saw a 75% reduction in the amount they were spending on SMSs because they didn't have to message everyone. They only messaged people who the agents decided were likely to respond to that kind of an incentive. And then if we're just looking at how our customers feel about what we do, yeah.
Sorry, we got a relevant question, and it was on a couple slides back, so I wanted to cover that quickly.
Yeah.
So a question came in on how do you define the number message? So hop back one more slide. And why is it so low? So we have a 10.8% number message rate. Oh, we said in that. So either way, how do you define percent message?
Yes, the number messaged, why is it so much smaller than the number of contacts, even for the one that we did? So there's two things. One, the number of contacts assigned was based on was all contacts, no matter how long they had been in the app. So there were a lot of churned users in these numbers. Also, there were a lot, even if they aren't churned, depending on your app, a lot of apps have upward of like a 40% unmessageable rate, where users have already turned off their messaging, things like that. And also, this was a snapshot for 1 week, so we didn't message all users every week. We messaged them when the agents thought we should. So there's several different reasons why that number goes down lower, though.
Cool. Thank you.
Let's see. This on the left-hand side here, you can see someone we work with who works with the rewards app messaged us this on our shared Slack channel, and I love it because they were able to see themselves. We didn't present the data to them to look at it. They were just looking at their numbers. And after they turned on an agentic system, they were able to just see the impact. The graph you see on the right-hand side is another one of our customers who back last year, they had a change in leadership, and the person who was our main contact in the organization texted us one day and said, we've had a change in leadership and they don't know what AMP is. We want to turn it off. And he said, I'm kind of worried about that because I know how much it's been doing. So can we turn it off in kind of a phased manner where we take a lot of the things that we think we could reproduce in a normal non-agentic system with triggers and segments, and we'll make those in the non-agentic system that we already have, and then we'll turn off those things in AMP, and we can monitor and see how it works. And you can see here very clearly where they decided to turn off the agentic system, and you can also see where they texted us in the middle of the night repeatedly saying they said we'll find the money, turn it back on. So you're able to actually see the impact in your bottom line results. And in fact, we make our data available. We consider any data generated by agents your data. And that is really maybe the main thrust of, or the main value that you get out of an agentic system. There's been so much focus on getting data, on bringing all of your data together, on leveraging all of your data. And the reality is the very most valuable data you can have is the data you generate yourself. All of the stuff you've collected about your users, sure, has some information in it. But when you actually try something and you see how the user responds, that is worth so much more information, so much more value. So an agentic system not only works more efficiently, helps you find hidden value, things like that, it does that by generating the data you need in order to make those decisions. It tries things, finds the results, and it feeds that back into the system and learns from itself, from its own history. That is a lot of information, but I think that's all the overview I prepared. Jim, do we have questions people have put in that I can answer? Or if you have other questions, please write them in the chat and we'll come to them.
Yeah, I'd say please put the questions in. I got one over DM that said, just in general infrastructure, can we define, because this looks relatively complex, how this integrates with like an existing stack?
Oh yeah, sure. So this is actually one of the pain points of traditional CDPs is you usually have to like build in an SDK. There's a lot of engineering work involved. But because an agentic system is a decision layer that can sit on top of existing infrastructure, it's actually minimally invasive. I don't know if that's the appropriate word to use for software, but when it comes to getting your data, no SDK required. If your data already sits in a system that can be queried, something like BigQuery, then it's a matter of just giving read-only access, and the system just pulls out information from the tables it needs. Because usually if you have instrumented your app, you already are storing your event stream somewhere. If you don't have it in some kind of queryable place, it actually can be as simple as periodically dumping your event stream data into a bucket on AWS or GCP or something like that. You do not have to worry about the cleanliness of that data. A lot of enterprises get hung up on, well, we know that data is missing in one place and that it's messy over here and we change definitions here. We need to solve all of that before we can use the data. That's true if you're working with humans, but agents are already working on a much more complex landscape than humans can. It can deal with that messiness. In fact, sometimes that messiness is actually signal. There are ways that the agents can use this. When it comes to actually pushing out information to your systems to present content in front of users, that's as simple as an API key. So if you already have a system like Braze or MoanGage or CleverTap or any of these systems that are used for sending messages, you can keep that system. It's fine. All we need is the API key, and you don't create any campaigns, nothing like that. It's just using AMP just uses those systems to deliver the mail. We also can do poll situations, such as in-app messaging under certain conditions. The timing depends on when the user triggers the thing in the app, but we can actually personalize the content based on what the agents determine, and you can just pull that from our API to get it into your system.
Cool. We have a couple questions that I want to roll through really quick. I think these two may be very similar. So one, is this framed as reinforcement learning ML agents? And let me show you this other one real quick. Also, what kind of agents exactly do you use in terms of machine learning? So do you want to handle those? And then there's another couple afterwards.
Sure. So yes, this is a reinforcement learning problem. If you're not familiar with reinforcement learning, it's basic like Pavlov's dogs kind of stuff, where you have an agent which starts off knowing very little. You present it with some kind of stimulus that says this is good or this is bad, and it's associated with other information. In our case, it's associated with the tags that you've populated. And over time, it learns to associate good or bad outcomes with certain tags. It tends to then pursue the stuff that it feels good about, and tends to run away from the things that it feels bad about. So that's basically how it works. As far as the specifics of what we do and how those agents work, that's probably a topic that we would not be able to cover in the time we have here. But I'm happy to talk about that offline or otherwise. But what it is, I mean, this is stuff that we built ourselves, so it's not just a layer on top of ChatGPT or anything like that. Sometimes people have questions about that, like, is this just a wrapper for GPT? It's not. So it's leveraging actually a whole bunch of different models in the background. That's why I say it's a little too much to talk about in this venue. But really, honestly, this is where I get very opinionated as a data scientist, so bear with me. In a reinforcement learning problem, the most important part of the problem is not the type of agent you use, it's how you define the action space. So the action space is the options that the agents get to navigate. For timing, it's times of day and days of week. For copy, it might be different value propositions. It's all the tags we talked about. Defining that well is much more important than the specifics of the machine learning that you're using on how to learn how to navigate that space. That's my strong opinion, and since I designed the system, that's been built into our system. But so we actually devote a lot more attention to figuring out that action space, which is why we actually modeled the entire content, the copy of your messages, as a knowledge graph rather than discrete action spaces. It allows for much more efficient learning, regardless of what kinds of algorithms you use. I don't know if that was the answer you were looking for, but it's the answer I have.
We can always, if you want more clarification, you can go into that. We did get one more question. So could you please help us understand more on the business objectives that this can solve? I don't know if you want to walk into more slides or just cover that manually.
So there, actually, yeah. Let me go back to the.
I think I can pop it up.
Here it is. I never get to use these slides. I'm kind of excited someone asked this. So there's several different business objectives we're looking for here. One is an orchestration problem. The businesses have a very difficult time orchestrating all of their channels. So it is common for different teams within even a moderately sized enterprise to run into traffic jams in the messaging. They all end up blasting the same users with 5 different messages because they didn't realize they were all targeting those same users. This becomes even more of a problem when you're trying to A/B test your way through things, because then you're running different tests, and if someone else decides to include the same users, part of the same users in their test, you've now confounded your test. So this allows you to manage all that orchestration in one system to do it automatically. Also, everyone wants AI. AI is difficult to build. I'm saying that for copious amounts of personal experience. It is hard and it's expensive. And when you look at the companies that have already been leveraging these kinds of methods, they have a head start. They built this in-house because they invested in huge data science and engineering teams. Companies who want to compete with those market leaders don't have the time to market to build the thing themselves. It's years and probably millions of dollars down the road. And so what this allows you to do is jump straight into competing for that market share rather than trying to build the whole thing for yourself. Another thing, a lot of personalization right now, when people talk about personalization, often it's as simple as, well, we want to put their name into the message, things like that, which actually, interesting thing. Some people find that like makes it more relatable. Oh, you have my name in there. I pay attention to that. Other people, that's creepy. It's like, why do you have my name in there? We're not friends. You're a business. The thing is, just like there was that one user I showed who only wanted a few messages and then would activate, and then there was the other user who actually wanted reminders all the time and they'd activate as often as they were reminded. There are people who like each type of that personalization. There are people who like each type of every kind of personalization, and there is no way to accomplish that without an agentic system. It's too high of a workload for a human team to take on. Also, this solves one of the core problems of traditional customer data platforms, which is you have lots of data and it's messy. How do we structure it for humans to pick it up? A synthetic agent can handle much more messiness and much more data, many more dimensions of problems than a human can. So instead of having to solve your data cleanliness problem, you can actually just go around it. And you can start getting value from your data right now, even if you haven't cleaned it. Oh, yeah, and this is what I guess this is worth mentioning really quickly. A lot of times people measure value in terms of clicks when it comes to messaging, because that's the thing that's easy to measure. But clicks aren't your bottom line. You don't make money from clicks, usually. You make money from people making purchases or actually watching the videos or listening to the music, playing the games, things like that. This system because we have to ingest all that information anyway for agents to be able to navigate those embeddings, you get those surrogate models almost for free, which means you can actually target the agents to focus on things that you actually care about, people actually adding to cart, people actually purchasing. That is much more difficult to do in a traditional system because it's not making full use of all of your data. Those are the main business cases I've come across so far that we tend to focus on. Yeah.
Great, thank you. We did, by the way, get a thank you. Got it. The knowledge graph is used as a function approximator for the action space embedding.
Yes.
So thank you, Sharad. Yes. There is another question. I was gonna pop up. My QA mode turned off, so I'm gonna see if it works. If I can do it again. Sorry, 1 second. Maybe I can't. All right, it was based on, let me turn that off so it's not distracting. Based on the statistical decisions of your ML agents, do you use LAMs to execute the decisions?
No, we don't. That's again a technical thing that we'd have to get into in more depth into how we make a decision. But the decisions are actually that's one implementation option. It's different from the implementation option we did. It's not a bad option. There's costs and benefits to each. What we have focused on so far is actually working on, and again, this is my bias as a data scientist, structuring the problem is more important than structuring the solution. The challenge of what method we use is actually down the list in priorities for us compared to the challenge of making sure that we're able to adequately represent the real business problems for our agents. So being able to represent the strategic priorities of the company, which are multidimensional, being able to set constraints effectively on what agents can or can't do under certain situations, being able to represent really what the priorities of the business are and all of the proxies for that. All of that is what we have focused on first, because that's where we believe the most value is, not only as a business, but also for a reinforcement learning system. The methods, I mean, if you think about A/B tests, if you go out and look at all the people who are like the data scientists who are talking about A/B tests, there are endless debates about experimental design, about p-values, about sample size, about stratified sampling, about power estimation, all of this kind of stuff. And in my experience and the experience of most people I've talked to who work in experimentation, those debates don't actually lead to any real business differences in business outcomes. What really matters is what you decide to learn about, what you decide your experiment is going to be, and how you act on that. And so that's what we tend to focus on more.
Perfect. We got another great data question. Let me pop into that really quick. So can you, wow, these questions are rolling in. This is good. Can you talk more about the types of messy data that you describe the system being good at handling? I'm picturing messy data as being inconsistent or missing representations of impressions or actions, which I find surprising the system can handle.
Actually, I'm continuously surprised at how robust our system is. I didn't when I built these agents, I didn't realize they'd be able to handle it so well. But as a matter of fact, yes. We have agents who, because of certain problems, they actually don't have certain data piped through for them, whereas other agents do have data piped through for them. Obviously, if no data comes through, that's not a surmountable problem for a data system. But even when they're missing large swaths, they're still able to learn with whatever they have. That's part of the strength of the embeddings and the surrogates, is that however much data you have, you're able to leverage that. You will learn more efficiently if you have wonderfully clean data and it's all complete for everyone and everything like that. But even if you do have a feature that was redefined 3 months ago, and so any data before that time means something different than it does now, stuff like that, you can still learn from that. It's just a messier learning. And what we found is even with very messy learning, even we've had customers who've given us very minimal data, they were still able to do things and get value beyond what their human teams were able to do. I think that's an important point, is that the baseline here is, what is your human team able to accomplish with your current budget? And the answer in most cases is they're not able to accomplish nearly as much as what you want and not nearly as much as what you need as a business. And so even if the performance in absolute terms isn't as good as it could be if you had all of this complete and clean data, it's still quite a bit higher than what you're able to accomplish with just your human operators.
That's awesome. We have a couple, there are a couple actually business related questions. Nothing I love more than tossing business questions to the data science guy. But there is one that was more technical I wanted to pop up really quick, which is the system resource hungry? So if there's one agent for every customer, how resource hungry is the system?
It's less resource hungry than it used to be. So we shoulder the cost of that. I mean, all this processing is done on our own systems, because we just pull in, like I said, we only just pull in the event data, process it, and then send it out through API to the different services. We're continuously working on making it more efficient. We find that right now, most of the resource bottlenecks for us have been in processing that complex network action space of the copy, and figuring out how to assign that. that we've built in several efficiencies that have reduced our costs dramatically on that over the last 2 years. But that's something we're constantly working on. AI is not AI is inherently a resource intensive thing. That's just what it is when you're processing that much information. But through the efficiencies we built in and the way we've designed the system, we're able to conserve that in a lot of different ways by just being imaginative in how we design the processing.
Cool. And I think the key point is this is, like you mentioned in the beginning, we shoulder that. So it's invisible. Yeah. That piece of it is invisible to most customers.
It's also important to, this speaks to the point I said about building versus buying. When we first started building this, we shouldered a lot more costs than we do now because it was difficult to know where we needed to build efficiencies and where we didn't. That's one of the reasons why building an AI in-house can really balloon costs quickly.
Mm-hmm. I think, so we got another question, which is, what was the reason for not exploring an LLM-based agent? Multimodal agents can analyze image inputs as well. So any you can say? Yeah,
so that's a really good question. We do actually allow our customers to leverage LLMs to generate content if they want. But we found, and actually multiple studies have shown consistently since GPT-3 made waves, most companies are not yet at a point where they trust LLMs, and I feel like that's fair. You cannot afford to have an LLM hallucinate to your users. Like that's you can go on social media and you can find a million places where even an intern caused a lot of problems for a company by posting terrible things. An LLM can easily do that. When we've experimented with this before, for example, just to give a simple example, we often find that an LLM will hallucinate discounts. And suddenly you'll be offering a 60% discount where you're not prepared to offer a 60% discount, things like that. So what we do is we provide quality control and brand voice consistency. This is where your human operators do something that a computer cannot yet do consistently, which is to look at it and decide whether it's reasonable or embarrassing or anything like that. And so we've made it so people can generate loads of content very quickly, even without an LLM. We do that through smart recombination of pieces of messages. But yes, for customers who care about it, and want to try it, we're always excited. LLMs are a very exciting development in the field of AI, and we do allow them to leverage that when they want to.
Yep, perfect. People keep asking technical questions, or else I'd pop into these business questions faster. But can you talk about data privacy and data security? We get this a lot, so I definitely wanted you to see that one.
We do. This is actually a question that's better for one of my co-founders, Sami Aboud, but who does more engineering stuff. But I'll take a crack at it. So we keep all of the data. We set retention on your data for whatever you feel comfortable with. So if you want to have us, we delete it whenever you want us to delete it. As far as where it's stored, we're built on top of Google Cloud. And we store the data in whatever region you care about. And we have all of the privacy and security assurances that Google has for its own systems. So that's the short answer. If you're wanting a longer answer, I would encourage reaching out and talking to Sami, because he could give you a much more detailed answer.
Thank you. We've also, too, we're selective about if you don't have to give us personal identifiable information and things like that as well. So you can control that gate.
Any information you want to retain, like for instance, if there are certain events on your app for some reason that you don't want to pass through, a certain metadata, you can also control that. Like, we only get what you want to give to us.
Perfect. I think there are two business type questions. So I'm going to pop them both up, and then I'll let you kind of take your, I think you can take a swing at both of these kind of at the same time. So one is, how do I compare you versus your competitors? The second is, how quickly do your customers see incremental uplift? So I'll let you handle those.
So how do we compare versus our competitors? Short answer and longer answer. short answer is that, in fact, I can bring it back up really quickly. What I showed here, I didn't name names before, but when I talked about their static system, that when we did this controlled trial, that system was Braze. So we've gone head to head with different companies in many different situations, and we come out looking good. But the kind of the larger answer to that is that in a way it's an apples to oranges comparison. For example, one of the main benefits that our customers get from using an agentic system is that where before they were looking at having to figure out budget to increase headcount to accommodate all the things they wanted to do with their CRM or their product, things like that. Once they switch to an agentic system, not only do they not have to raise that headcount, but also the people who are existing working on the system suddenly find they have more time to do things that only humans can do. Whereas before, they were spending a week aligning on what their experiment would be and bringing like that. Think of how much people are paid in your organization, reduce that to how much they get paid per hour, and think about how many hours those people had to spend in a week to align on a single experiment. That now gets reduced to a few seconds that you write that message, because the way the system works is if you try something and it doesn't work well, the agents will pull away from that and they'll stop using it. They stop the experiment on their own. And more often than not, what they'll find is a small niche of agents say, actually, this really works for my people. And then you get it just to them, and the rest of the people don't get it. There's tons of resource savings and time savings from this. So even if, the system performs better than the competitors, but even if it performed the same, you're still able to do more with it because you're able to offload a lot of activity that normally you'd have to increase your headcount to do. What was the other question? There's competitors.
Just how soon to incremental value?
Oh, we find that agents can get opinionated on copy within a couple weeks. They get opinionated on timing a little bit longer than that, more like a month, just because you have to go through a few complete weeks for them to really get a feel for what's going on and what user patterns are. We find that usually you can start seeing something moving in a positive direction after a month or two. Like where you can actually see it. It's moving in the positive direction already, but where you can actually see it in your results. You can usually see it within a month or two. You can see it more decisively usually after 3 or 4 months. But like I showed from the example of that customer who texted us, like she sent us that Slack, I think like 3 or 4 days after they turned us on. So in some cases, you start seeing value immediately. A lot of that depends on the data you're giving the agents, the option, how well you've encoded your different priorities in your tags and created content to populate those tags, and also just your user base. Every app is different. And so there are some cases where agents are able to, you have more stability in your user base inherently, and therefore agents are able to arrive at a solution quicker. But yeah, usually to feel confident about the results you're seeing, I would guesstimate around 2 to 4 months, but keep in mind it's different for everyone.
Mm-hmm. Let me do this real quick. We're a little long, but this is a really good question. So I want to do one more question, and then we could summarize and wrap. So this one I thought was good. Do the customers get the option to customize their agents based on their business needs, or is it already built solution that always follows the same algorithm?
That's a great question. Yes, you do get to customize them. There's several different ways you do that. So, like I said, agents work creatively within constraints. So you set the landscape, the boundaries of where they can go, and then the agent decides where to go. So you set your priorities in terms of what are your events that you care about? What does conversion mean to you? You set your strategic priorities in terms of setting out different kinds of value propositions, the different offering categories you care about, stuff like that, that creates that content landscape. So they're not going, if you're a food app, they're not going to message about pizza unless you tell them that pizza exists. So there's building out that landscape. There's also generating or putting in constraints on expectations, such as I want everyone to be messaged at least once a week, or I want to make sure we never message anyone more than 8 times a week, something like that, or per day, whatever it is you care about there. So you can be opinionated about what constitutes a good user experience in general. We usually encourage you to keep those to cast as wide a net as you can, to put in as many different value propositions as you can think of, to set those frequency constraints as loose as possible, so agents are able to find those niches of users who really do live at the extremes, and that's how you reach them. You're also able to get a little more involved, like granularly involved, by controlling the content. So if you create particular messages associated with certain tags, and you find we provide analytics on how these things are performing, and you say, oh, okay, that's something I really think is useful, you can generate more content to give the agents more ammunition. You can also look at something and say, you know what, I've seen enough. Even though the agents are learning on this, I just don't think it's worth doing anymore. And you can get rid of that, and the agents, they don't remember it anymore. So there's lots of different ways. You can also set specific audiences. So an agent will only consider certain content for people who meet certain criteria. You can set certain triggers, such as like an abandoned cart, so the agent can know when a user meets these certain conditions, they are now available for new content. You can do all of that stuff to influence like I said, the landscape that the users, that the agents operate in. The agents will still operate independently within the boundaries you've given them.
Perfect. So can you give us your 5-sentence summary, and then we'll wrap it up.
Sure. So, agentic methods aren't entirely new. They just haven't been evenly distributed across companies until now. The companies that have been using them so far have been hoarding that resource for good reason. It's very valuable. But increasingly, those kinds of systems are becoming available as plug-and-play solutions. And that is where the real opportunity is, where if you want to get into this game, you no longer have to wait several years and several $1 million to get to market. You can actually go immediately. And the benefit is not just the increased performance. That's one way of looking at it. It's decreased dissatisfaction among your user base, because you're no longer annoying them with irrelevant content or pestering them with too many notifications. And it's also reducing the amount of resources you need to devote as a business to these capabilities, because you're offloading a lot of that into synthetic agents that are able to take on some of the workload that until now you've been paying people to do, instead of having them do the things that only people can do. There are certain things computers can do, and there are certain things only humans can do. And you get the most value from your business when you efficiently give humans just the things that only humans can do. Let them spend their time on that, and let the computer pick up the slack of the rest of the stuff. I guess that was more than 5 sentences, but that's my summary.
I somewhat expected that from you, but that's all right. That's all right. All right. Well, thank you all for joining. We'll make sure that we have a video. We can send out a video. If there are any other questions, like I said, you can just email me, jim@amp.com, or hello@amp.com, or get@amp.com, or pretty much anybody at amp.com will help you, but feel free to send them my way. Thank you for joining me, Sean. This was awesome. And we will see you on our next webinar.
All right. Thanks.